Hi everyone, I am Dr. A.R. Vijay Babu, working as an assistant professor in Department of EEE Vignan's Foundation for Science, Technology and Research, Dimut to be University. So we are discussing the Unit 5 of EACM, that is Energy Audit, Conservation and Management, that is Energy Efficiency in Space Heating and Ventilation. We have already gone through what is an HVAC system, what is the need of an HVAC system, and we have gone through different types of ventilation systems. So coming to the learning objectives of this unit number 5, we are going to see what is a HVAC system. What is HVAC? Heating, ventilation and air conditioning system. And then we are going to see what is the need of HVAC. And later we are going to see what is ventilation. And then what are the different types of ventilation systems. And later we are going to see heating and what are the different types of water heating and space heating systems. Later we are going to see what is air conditioning, and then we are going to see the working principle of air conditioning, that is vapor compression cycle. And later we will see what is the working of an air conditioning system, and finally we are going to end this unit with energy conservation measures in HVAC. Now let's focus our attention towards heating. So what is a heating? Heat is a form of energy that can be transferred from one object to another or even created at the expense of the loss of other forms of energy. So how this heat can be transferred? There are three different ways the heat can move. The first one is either through conduction, and the second one is convection, and the third one is radiation. As you can see in the figure, conduction will happen through direct touch, whereas convection will happen through a medium, and the radiation will happen through electromagnetic radiation. Now let's discuss the first mode of heat transfer, that is conduction. So heat is transferred by direct contact or by direct touch. The phenomena takes place in solids, liquids as well as in gases. Here in conduction there is no actual motion of the molecules taking place. So what are the examples of this conduction? You burn your hand on a hot pot as shown in the animation over here. When you touch the hot pot which is being heated on a pan, then automatically it will get heated up and automatically your hand will be burned. Even though the part which you are touching is not directly heated by the fire, you will feel the heat or a burning sensation, and that is because of conduction. The heat transfer happening because of conduction in this case. So hot soup transfers heat to the spoon. And the third example is you barefoot loses heat to a cold tile floor. When you stand on a tile which is cold, what happens? That cool tile will take away the heat from your feet, and because of that you will feel a cooling sensation. Not because that tile is cool, because you are losing the heat from you, you feel that cool. Now you can see here conduction. So when you heat a metal strip at one end, the heat travels to the other end. How? As you heat the metal, the particles vibrate, and these vibrations makes the adjacent particles also vibrate, and so on, layer by layer, and the vibrations are passed along the entire metal, and so is the heat along with the vibrations. So we call this conduction. As you can see in the figure over here, now when I take a solid material, if I supply heat at one end of the material, now you can see the layer which is closest to the heat will be heated up and vibrations will be passed to the succeeding to the adjacent layers, and thereby it reaches the cool end of the metal strip. So the complete metal strip will be heated up because of the vibrations taking place inside that metal strip, and along with the vibrations the heat also will be passed on to the adjacent particles, and this is nothing but conduction of heat. Now you can see here, for an example, I have taken a cup full of soup, and when I kept a spoon inside it, when you touch the cool end of the spoon, your hand will feel the warmth of it. Why? The spoon has two ends, so one end which is kept inside the soup is a hot end, and the end that is outside is a cool end of the spoon, right? Now what happens? Or nothing but a spoon handle. Now what happens? The heat is transferred from soup to the hot end of the spoon, and that heat, because of the vibration of the particles, will be reaching the cold end of the spoon or spoon handle. Even when you touch the spoon handle, it feels hot, and this heat transfer is because of conduction, and this happens because of the motion of the particles through the material. Now let's see the second mode of heat transfer, that is convection. So heat is transferred within the fluid. The fluid may be either liquid or gas by the movement of particles, and this phenomena takes place in liquids and gases. So heat is transferred due to actual motion of the molecules in convection, whereas heat is transferred in case of a conduction without the actual motion of the molecules. But in case of a convection, heat is transferred with the actual movement of the molecules. The examples of convection are a boiling water and a fire heating the room. Let's take the first example to understand this. Let's take a kettle full of water, and when I heat it at the bottom, what happens? The bottom layer of the water which is near to the heat will be heated up, and once the water gets heated up, the density will be decreases, and thereby the hot water will move to the top and cold water will come to the bottom, and again the cold water gets heated up and again will go to the top, and it creates a circulation current inside a kettle, and it is the reason why the heat gets accumulated or gets transferred to the liquid inside the kettle. Now let's take the example of a fire heating the room. So when you have a heat radiator in a room, the cool air will be taken by this heat radiator, and it will heat that cool air, and whenever the cool air got heated up, it will move to the top of a room, and the cold air which is at the top will be pushed downwards, and it will be again passed through the heat radiator, and again the heat radiator will heat the cool air, and the cool air will become hot air, and the hot air will become less dense, and it will move to the top, and the circulation repeats, and this is how the air inside the room is completely heated up by means of convection current. Now let's see the third heat transfer mode, that is radiation. So heat is transferred through space by electromagnetic waves. Here also there is no touching. So what are the examples? The fire warming your hands. So when there is a fire and when you go there to warm your hands, what happens? Your hands will be warm. Why? Because of heat transfer through electromagnetic waves. In this case, you are not touching the fire, even though your hands are getting warmed up. It's because of the heat transfer through electromagnetic waves. And the sun heating the earth. Now you can see here how the heat energy get from the sun to the earth, right? There is no particles between the sun and the earth, so it cannot travel by conduction or by convection. There is no possibility of conduction and convection between the earth and the sun, because it's a space which is devoid of all the particles. So it should be definitely because of electromagnetic waves, and that's why it is called radiation, and that's why we call it as solar radiation. Now let's come to the next topic, that is water heating in buildings. So the hot water is used for domestic purposes or for meeting the needs of industries and commercial establishments. So the water heating systems can be classified into two categories. Number one, natural circulation system or thermosiphon system. Number two, forced circulation systems. Now let's see one by one in detail. So natural circulation system using solar energy. So you can see the figure. In that figure you can clearly observe that there is a solar water heating system. You can clearly see it. The collector is located at the bottom, whereas the tank is at some elevated position. Now let's see the operation of this natural circulation system. The two main elements of this system are the solar flat plate collector and the storage tank, that is located above the level of the collector. Here in this natural circulation system, always the storage tank is located above the level of the collector. So when water in the collector is heated by solar energy, it flows automatically to the top of the water tank and is replaced there by cold water from the bottom of the tank. That is, initially we will fill the tank with the cold water, and when sun is shining in the sky, the cold water will be made to pass through the collector, and the collector, by taking the sun's energy, it will heat the cold water, and the cold water becomes hot water, and the hot water will move to the top of a tank, and they will be stored in the same tank. So when the hot water which is stored in the top component of the tank is withdrawn from the tank, the cold water enters automatically from the bottom side. So in this arrangement, an auxiliary system is also provided for use in cloudy or rainy days. So during cloudy or rainy days, we don't be having any solar energy, and thereby we will use an auxiliary heating system to heat the water. Now let's discuss the important component of this water heating system, that is flat plate collector. A flat plate collector consists of an absorber plate on which the radiation of the sun falls. After having come through one transparent cover made of plastic or glass, either single or double glazed, the absorbed radiation is transferred to a liquid via the absorber plates. Now let's see here what happens here. Whenever sunlight falls on the flat plate collector, it first strikes the glass sheet, and then the solar energy will be absorbed by the absorber surface, and on the absorber surface we will keep the tubes, and inside the tubes there will be a cold water, and this absorber surface, which is getting heated by the solar radiation, will transfer the heat to the water which is there inside the tubes that are placed above the absorber surface, and because of that the liquid which is there inside the tubes will get heated up by picking up the heat from the absorber surface. In place of water, we can also use oil. That is, we can also heat not only water, we can also heat any other types of liquid. Say for example oil in this flat plate collectors. Now let's see the forced circulation system. So before going to the forced circulation system, what is the main drawback of this thermosiphon system or the natural circulation system? So the main drawback of this thermosiphon system is that the storage vessel needs to be located higher than the collector, which means the collector may have to be sited on the ground. So always the collector or the flat plate collector have to be kept on the ground, and the storage tank has to be kept on the ceiling. Right. So this is the main drawback with this forced circulation system. So when large amount of hot water is required for use in industries, forced circulation with water pump is employed. So the restriction that the storage tank should be at a high level can be eliminated if I go for a forced circulation system. I can keep them side by side. So water from a storage tank is pumped through a collector where it gets heated up and then flown back into the storage tank. So whenever the hot water is withdrawn for use from the tank, automatically the cold makeup water will take its place at the bottom. But tell me one thing, how the water will move if both are kept at the same elevation? In the previous case, the water will be moving from tank which is there at the top to the collector which is there at the bottom, naturally. And once the water gets heated, the density of the water decreases, and thereby the water straight away moves to the top of a tank. It is called a natural circulation system. But in this case, in case of this forced circulation system, I have kept the collector and the storage tank side by side. But how the water will move from storage tank to the collector and from collector to the storage tank? And this will takes place by means of an auxiliary device called pump. Here the water will not naturally flow into the system or naturally flow into the collector from the storage tank. It will happen forcefully by means of a pump, and that is the reason why we call this system as a forced circulation system. So when you are utilizing this pump, there is no need to keep the solar collector at the bottom level and tank at the top level. You can keep them you can keep both of them in the same level, that is at the top of your building, so that you can get the hot water from this system. See, the pump for forced circulation is operated by an on-off control which senses the temperature difference between the temperature of the water at the exit of the collector and inside the storage tank. So the pump is switched on when the temperature difference exceeds a certain value of 8 to 10 degrees centigrade. Say for example, there is a controller to switch on and off the pump depending upon the requirement of hot water. Now this controller will senses two different inputs. The first input is the temperature of the water at the outlet of the collector, and the second input is the temperature of the water inside the tank. And once these two temperatures are measured by means of thermostats or thermocouples, then the collector will subtract these two values. It will subtract these two temperatures. That is the temperature at the exit of the collector and the temperature inside the tank. If the temperature difference is in between 8 to 10 degrees, what it indicates? It indicates that the water which is there in the tank is not heated properly, and thereby automatically it will send a signal to the pump to bring the water from tank to the collector to get heated up. And now the pump will on and the water is driven into the solar collector and the sunlight will heat the water, right? And on the other hand, if the temperature difference will be in between 3 to 5 degrees centigrade, which means that the tank is heated up, the water inside the tank is also heated up, and there is no need to again send the water into the collector, and thereby the controller automatically will send a signal to the pump to turn it off, as there is no requirement of the hot water, as the temperature inside the tank is within the prescribed limit. Fine. So the provision is also usually made for an auxiliary heater in case of cloudy or rainy days. Keep in view the sunny or cloudy days. Now let's discuss space heating. That is nothing but heating of buildings. Space heating is of particular relevance in colder countries where significant amount of energy is required for this purpose. In India, it is of importance mainly in northern and northeastern regions in winter because they are very cooler. The space heating systems are classified into two types. The first one is space heating system using passive method, and the second one is space heating system using active methods. Now let us see these two in detail. Now let's see the space heating system using passive method. And this passive space heating system is otherwise called as a Trombe wall. And how this system will work? A Trombe wall is a south facing masonry wall covered with glass, spaced a few inches away. That is, as you can see in the figure over there, there is a masonry wall or a concrete wall, and the wall is located on the south side of the building. Now what you will do, you will take some few inches gap and you will install a glazing, that is a glass. So in between the glass and the wall there is some space. Now when sunlight passes through the glass, the solar radiation is absorbed and stored by the masonry wall. So this masonry wall, as you can see, it has two vents, one at the top and the other at the bottom, for the circulation of the hot as well as cold air respectively. So what happens now? Heat is transferred by conduction as the masonry surface warms up and is slowly delivered to the building some hours later. Now let's see the working principle. Solar radiation is absorbed by the blackened surface and stored as a sensible heat in the masonry wall. So we have intentionally kept some space between the masonry wall and the glazing. So in between these two we have some air. So the air in the space between the glazing and the wall gets heated up because of the solar radiation falling on the glazing is transferred to the wall. In between you have the air, and this air will get heated up, and whenever the air gets heated up, its density will reduce and the air will move upwards, and there is a vent which is available at the top side of this masonry wall, and automatically the hot air will enter into the room through that top vent. So whenever the hot air enters into the room, it pushes the cold air downwards. So the cool room air takes its place through the lower vent, thus establishing a natural circulation pattern. That is, so whenever this hot air pushes the cold air downwards, this cold air will be coming downwards and finds a vent at the bottom of the wall and will move through the vent. And again, now the cold air will be there in between the glazing and the wall. And whenever the sunlight falls on the glazing, now the cold air will take the heat and it will move upwards and passes through the building through the upper vent, and again it pushes the cold air inside the building to the downwards, and again cold air will be coming in between the glazing and the wall through the lower vent, and again this cycle repeats, right? And the principle is convection, right? So the distribution of heat into the living space or the room can be almost immediate or delayed depending upon the air circulation. Now let's see the active space heating system. The active solar heating system uses solar energy to heat the fluid. The fluid may be either liquid or air, and then transfer the solar heat directly to the interior space or to a storage system for later use. Now let's see the working of this active solar space heating system. An active method is one which utilizes a pump to circulate the fluids involved in space heating system. As you can see in the figure, you have 5 components. The component A is called a collector system, that is a flat plate collector. The component B is a storage tank. The component C is a pump because it's a forced circulation system. And component D is an auxiliary heater which is there in view of cold or rainy or cloudy days. And there is one more important component here which is called heat exchanger, E. It is a water to air heat exchanger or air to air heat exchanger. Now let's see the working. So in this system, water is heated first in a solar flat plate collector. But how the water will be taken to the flat plate collector? By means of a pump. See, there are 2 pumps here. By means of a bottom pump, water will be taken to the flat plate collector. And then the water gets heated up. And that heated water will be again moved into the storage tank B. And now the pump C, which is there at the top of this storage tank, will now act and circulates the hot water into the heat exchanger, where, as you already know, a heat exchanger is a device which transfers the heat between the fluids. Here the one fluid is a hot water and the other fluid is a cold air which is there inside the room. So through one end of this heat exchanger, hot water is circulated. So from the other end, the cold air is circulated through the heat exchanger, and automatically the temperature of the hot water will be transferred to the cool air, and the cool air will become hot air and get circulated inside the room, and it will provide the necessary space heating. And on the other hand, the hot water which has supplied the heat to the cold air will become now cold water and again will be moved to the storage tank, and from there again that water will be taken to the flat plate collector, and again the water gets heated there and again come into the storage tank, and again the water will be again circulated to the heat exchanger to convert the cool air into hot air, and the process repeats. It is how the active space heating system works. So 2 pumps provided forced circulation between the collector and the tank, as well as between the tank and the heat exchanger, right? So provision is also made for additional auxiliary heater D, keeping in view of the cloudy or rainy seasons. Now let's enter into a different topic, that is electric water heating system. So electric heating is a process in which electrical energy is converted into heat energy. This electric heating works on the principle of Joule heating. And what is Joule heating? This Joule heating is also known as resistance heating or resistive heating or ohmic heating. It is the process by which the passage of an electrical current through a conductor produces heat. You can see it as an example in the figure. Whenever you pass the current through a conductor, it produces heat, and this concept is called Joule heating, which is utilized in the electric water heating systems. Now let's see the concept of resistive heating. So this resistive heating is based on the principle of Joule heating, that is an electric current through a resistor converts electrical energy into heat energy. So whenever current is passed through a resistor, heat is produced because of I square or losses, right? You can see in the figure, whenever there is a material which is having a resistance R, when you supply the current through it, you will get the power loss of I square R or V square by R or Vi. Generally we termed it as I square R losses, and these losses will dissipate as heat. So let us take the case of a solid material which has a resistance of R ohms and the current flowing through it is I amperes for T seconds. Then the heat produced in this material will be I square RT joules, and this is the amount of heat which is getting dissipated because of passage of the current through a conductor. Now what are the examples of this resistive heating? There are 2 commonly used examples in our home. The first one is an immersion heater and second one is a geyser. Now let's discuss the operation of these 2. Now let's discuss the immersion heater. So the essential parts of a basic immersion heater are: number 1, metal tube; number 2, heating element; number 3, filling material; and number 4, power cord and plug. So as you can see here, the metal tube is a basic immersion heater. So in a basic immersion heater, the metal tube is a copper tube in suitable shape. You can see in the figure over there, copper sheet. The metal tube is made of copper sheet. The copper tube is chrome plated. So the copper tube is chromium plated. That is, it is coated with chromium on top side of it. So the chromium coated copper sheet acts as a metal tube in case of a immersion heat. So the second element is a heating element. So the heating element which is used is nichrome coil. So nichrome generally refers to an alloy of nickel, chromium and often iron and or manganese and silicon. That is, what is nichrome? Nichrome has two combinations. The first combination is nickel, chromium, iron and silicon. Second combination is nickel, chromium, manganese and silicon. Right. The alloy which is formed by these kind of materials is called a nichrome alloy and which is used as a heating element. The heating element is stretched concentrically inside the copper tube. Right. The third part is a filling material. So the filling material is an electrically insulating but thermally conducting material and the tube is filled with filling material. And the copper tube, as you can see there, is filled with magnesium oxide. Because magnesium oxide is generally used as a filling material in immersion heaters, and this acts as a insulator for electricity whereas a conductor for heat, right? And then the fourth part is a power cord or plug. So they work with 230 volts AC power supply with power ratings usually between 250 watt and 2 kilowatt depending upon the capacity of the heat. Now let's see the working of this immersion heater. An immersion heater is an appliance used to heat water or some other liquid kept in a container. So the immersion heater is partially immersed in water or the liquid and is switched on, and then the water or the liquid gets heated up. So the working principle is based on law of convection. So whenever you dip this immersion heater into the water, now what happens? The cold water always remains at the bottom as it is denser than the hot water. As the water gets heated up, it expands and moves to the top of a bucket or a tank in which the immersion heater was kept. Right? Whenever you place this heater inside the water which is there in the vicinity of this tube, concentric copper tube, will get heated up, and because of this the density will decrease and thereby the water will move upwards and cold water will come downwards and again gets heated up, and this forms a convection current, and subsequently the water in the bucket will get heated up. Now let's discuss the second water heating system, which is a geyser. Generally the electric water heaters have two heating elements, each wired with a thermostat, as you can see in the figure. Both the heating elements do not function simultaneously. One is at the top, another one is at the bottom. You have a top heating element and a top thermostat. You have a bottom heating element and a bottom thermostat. Right. Now let's see the operation. Initially, the top heating element functions until the upper tank is hot, and then the function is transferred to the bottom heating element which has its own thermostat. So usually water in the upper tank is heated from 50 to 60 degrees centigrade before the control is transferred to the lower heating element when hot water is consumed. Once again cold water enters through the dip tube and the process is repeated. As you can see in the figure, initially there is a geyser which consists of two heating elements, upper heating element and lower heating element. Initially the upper heating element is on, and thereby the upper part of the water gets heated to around 50 to 60 degrees, and then the control is transferred to the lower heating element, and then the lower heating element will heat the water which is there in the bottom component of the tank, and the complete tank will be now heated, and again the process repeats. It is how the geyser will work. The two heating elements which are there inside a geyser will not work simultaneously. They will work one by one.